So welcome back. We have 4 exciting sessions today, 3 sessions and 1 panel discussion. The first session is an international session. We have people from US and Europe. And so the first speaker is Peter Dodds. He's from University of Vermont. And he's going to talk about measuring the happiness and health of populations in real time using an unexpectedly tunable pedometer. Interesting.
It's the longest title I could come up with. So welcome. I realize it's very early. I appreciate you coming. Yeah, I have a lot of things I could talk about, and I've tried to get rid of most of it, but there's still a fair amount here, so I need to speak with some rapidity. I'll be presenting this instrument, if you like, for measuring happiness from large-scale tests. And I'll show you what we initially did. We've been through a lot of iterations, where we are now, and how it's improved very much in the manner of a physical instrument. You know, it's kind of like polishing a lens and being able to see more things, as it would say with a microscope, and where we're going in the future. And I'll give you a bunch of results, little pieces here and there. So to start with, so it's Valentine's Day. So this is just another piece. So this is our measure of happiness, which I'll explain. And this is comparing across maybe 300, 400 cities, close to 400 cities in the US, or urban regions, census regions. So this is a percentage of population married in those regions. So it's a big scatter, but it's a nice correlation. So happiness and marriage kind of go together. So that's a good story. It's a good story, right? That's a good story. Another good story for speaking first in the morning is this picture. So this is what I call the daily unraveling of the human mind. This is based on our measure from Twitter data. And that previous slide was Twitter data as well, so we have geolocated tweets. And obviously there are all sorts of problems with sampling. Yes, we can get into all those details. But this is a repeated averaging of a cycle over a year or two. And so this happiness score, which I'll explain, peaks around 7 in the morning and then goes down steadily during the day and starts to pick up again. So people, it depends who's awake at those times tweeting. So we lose it a little bit, and something to confirm that is here are 5 swear words you can't say on television. Very different words, they have very different frequencies, but they have the same pattern once you normalize them. So those are going up through the day, and then you start again in the morning, drink your coffee, you reset. So we're kind of like Windows machines. We need to be rebooted every night. So we have a group that, so my colleague Chris Danforth, we co-run. In a sort of anomalous kind of way for academics, I suppose. And we're a computational story lab. We have a really great team, lots of fun, and lots of progress going on. So this is Danforth, by the way. I like to show this. This is some ridiculous race in Vermont. This is about 4 hours into it, jumping over a fire pit, trying to survive. So we put some of the students through that as well. All right, so a little bit of motivation. Why do we want to measure happiness? So this is Greenspan from 2007. Recall that some things happened after that point in time. So I'm going to read out a comment he made on a TV show. So I've been dealing with these big mathematical models of forecasting and not the economy. If I could figure out a way to determine whether or not people are more fearful or changing to more euphoric, I don't need any of this other stuff. It's a bit of a bold claim. I could forecast the economy better than any way I know, which I'm pretty sure is not true, but basically he's sick of his models. He goes on, so the trouble, he can't figure out how to do that, right? Been there for 50 years, no one's any good at predicting anything than they were back in the day. And he has this, the reason is that human nature hasn't changed. Well, if it hasn't changed, we should be able to figure it out. So we can't improve ourselves. This was actually talking to John Stewart. It's a great interview. There's a lot of interesting stuff in there. And of course, Stewart's reaction was one of those lines from him. But it's a very interesting piece. It's still up online. All right, so there you go. That's an interesting point in time. I like measuring things. We all like measuring things. With science, you have to measure and explain, but measuring can be hard. Right? So describing things can take a while. This can be upsetting to people who love theory, of course. But testing theory with the horrors of reality is a good thing to do. So this is Lord Kelvin. To measure is to know. You cannot measure it. You cannot improve it. And we often make a mistake of the things that we do measure, we focus on. It's too easy to do that. So there's also, he said, this is pre-1900. There's nothing new to be discovered in physics, just more and more precise. So you can't think of it. That's true. All right, so a little more on happiness. So it's been going on for a long time. Socrates, we go back in time, we talked about eudaimonia, this flourishing of the human spirit. There's all sorts of complications to these stories. Bentham talked about measuring happiness as a possibility, and this idea of the right action being the one that maximizes our happiness for all. The pursuit of happiness, right? So it's a line that we love in the US. And actually, this is a joke, right? There's life, liberty, and happiness, and there were some other ideas beforehand, but it really was property. Property really was, it was life, liberty, and property. And that just didn't cut it when it got to the editing floor there. So, all right, so this is just to say that it's not just these people who have great lives who say that we want happiness now, that everyone is feeding us food and so on. Average people say this. There's evidence that happy people that are in some sense happy live longer. There are complications, as is well known, the Easterlin paradox, that as you get more and more money than wealth, then happiness doesn't necessarily go up. So there's all sorts of interesting things there. And so, of course, some places have created these national indices of well-being. How do you measure those things? Usually by asking people. So an easy knock, and maybe this is not for you guys, but just, of course, people will say this, that the science we're doing is Orwellian, and that we're watching people's behavior, and the policy that you could easily end up with if you focus on happiness is give everyone soma, and then we'll maximize happiness. Now, what we're trying to do here is create another dial on the dashboard of society, right? So we want something else. We have GDP. We want to add some other instruments to that. And so we're trying to measure a ridiculous thing. We're trying to measure happiness. And you'll see it's fallible in various ways, but this is what we want to do. So we want to remotely sense, ideally. This is the kind of thing that we enjoy coming from the hard sciences. We'd like to remotely sense emotional states. Real time would be great, and then averaging over long periods of time. We need these things. We need it to be fast, of course, so we can do the real time with lots of data. It needs to be transparent. That's our personal preference. Written expression is great because of things like tweets, but also all sorts of other data sources. We need to have human evaluation in there somewhere. It can't be done in real time, obviously. Non-reactive means that we're not asking you how happy you are. And this is fine. That's a fine thing to do, and that's what's been done for many, many decades. We'd like our work to be complementary to so-called self-reported measures. And improvable. I'll show you how we improve. So we were digging around trying to get something to, essentially trying to get some sort of signal out of what we would call happiness or positivity out of these data streams. And there's a lot of flatlining coming out when we were using natural language processing methods and all sorts of things, which are hard to use in terms of scaling up. So we came across this study, very simple. People were just asked how they would rate individual words. And they're given about 1,000 words. These were hand-chosen by psychologists. And it goes back in time. But basically, it's kind of like a Netflix scale in a way, or an Amazon scale. There are these 5 pieces. People see that, but there's sort of a half element to it. So, very sad to happy. The way it was expressed was a very sort of general positivity. You know, you're excited at this end, you're happy at this end. So it's really kind of a catch-all dimension. There are a couple other dimensions you can add. This is psychology. This is going back in time. Excitement levels and dominance levels, and that there's this claim that covers a lot of emotional space. But we're going to focus on what's called valence or happiness. Here's what we do. Very, very simple. Take a text. Here we have the lyrics for Billie Jean. Simply find all the words for which we have individual average scores. Right? When people evaluate them in isolation, so obviously that's a huge problem because we're removing context or ignoring context, which is a massive part of particularly English, but we'll get to that later on. So we simply count up the number of words that we have scores for, we take an average of them, and we'll end up with some number, and the way this works is between 1 and 9, but it's usually between, say, 5 and 8. So 7.1 for Billie Jean. If you take a little Thriller, you get 6.3. I'll give you some sense of these numbers as we go on. That's an ongoing issue, of course. Calibration. Michael Jackson's whole opus, 6.4. So we would never think that we could evaluate a sentence. It's a bit like telling you what the temperature of a molecule is. It's not a good idea, right? So, but a small patch, we can say something about it, and we have ways of estimating our confidence levels as we move up. So we can tell you all about it. We've been more confident, for example, about, say, all of the songs produced or written in a particular year, and so that's what this is an estimate of. This is using our initial method, this ANU, this is what's called the effective norms for English words list. Again, 1,000 words. It includes things like pancakes, church, ski jump. So it's sort of a funny list of words, and we'll fix that up in a little bit. So it's a bit of a rough measure. You can see that kind of jumping around here, it's not producing a beautiful curve, but this is going from 60 to 2010. So this decline in the sentiment of music lyrics. So this is weighting music lyrics one at a time. It's not weighted on popularity in a sense. It's really just, Thriller gets one vote in that. Okay, so if you break it out, this is looking at song titles. Song titles are good because you get a lot of information into a song title. You throw away a lot of other pieces. But this is just using this instrument, this very naive instrument, does a pretty good job, right? So gospel and soul pop out the top. There's pop, then reggae, rock. This is in order. Rap is down about here. And then we have punk, and heavy metal is at the bottom. Good race. We have this word shift thing, which is a bit complicated. It's hard to say, but we want to compare these two word bags, right, and or any two bags of words to see why one text is happier than another, according to our measure. So this is music after 1980 compared to before 1980. So afterwards, you have less love and less baby and less home and less music, but a lot more hate, pain, death, dead, sick, fear. So this is it's the advent of heavy metal, right? So it's not just and other similar kind of music. It's not just the song kind. It's also the emotional niche that they fill, as we saw with this. So all right, so you can do fun things. You can look at the top list, right? So we have the Beach Boys, S Club 7, lots of positivity up the top. This is just sort of a sanity check, and these are the guys down the bottom. These are somewhat negative bands. I think you're right. But some people, of course, quite enjoy it. So happiness is a complicated thing. All right, so it does a pretty good job just saying with something as simple as music lyrics. This is age. This is what people expected theoretically, that it would, this is people expressing themselves on blogs. So those 13 and 14-year-olds are right down here. 45 to 60, good time, at least in terms of how people present themselves. And if you look at the words, this is looking at middle schoolers compared to people in their 40s. So they're saying depressed, bored, lonely, alone, mad, pain, upset, fat, dead. So again, kind of a reasonable, if you have a teenager, you might understand that, or if you've ever been one. So I'll flip through some of this. So what we did is we moved up to a much larger data set, 10,000 words, based on the most frequently used words in the New York Times over a 20-year period, Twitter for several years, Google Books, again for hundreds of years there, and music lyrics for about 50 years. So we took the top 5,000 words. So we're including the and of, and right, we're using those as well, but then moving out to the top 5,000. So if you merge those, you get just over 10,000. We went to Mechanical Turk, and one of our next steps is to go to a different service and move it out to about 10 languages, and simply repeated this ANU story. So, reasonable things come out, right? Laughter, happiness, love, they're all at the top. This is just the top few. Music, celebrating, they're all up there. These are the negative ones, so terrorists down the bottom, suicide, rape, all these bad words. So, it makes sense, and the neutral words, these on average 5, so we're getting reasonable things out. But now we have a much more refined instrument. These are the words that people have the largest standard deviation for, right? So there's a lot of swearing, there's alcohol, there's cigarettes, church is in there, zombies is in there, and some stuff about capitalists and McDonald's. So people, these are the things that people are not really sure about. So it's funny to look at what women say in these evaluations as well. All right. So, Twitter gives us great words like ha, 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 and all sorts of things. Okay, so this is something I really wanted to point out, so that if we take these 10,000 words and simply bin them, these average scores, then we see this distribution, right? It's not normally distributed around or evenly distributed around neutral, which maybe you might expect, or maybe it's more negative. It depends on your kind of view of the world. And this is true for all these 4 corpora individually, right? So this is Twitter, Google Books, music lyrics, and New York Times. You can see this. The yellow is showing you what's above neutral. So there's a positive bias sitting here, which we found to be extremely interesting. This is another way of visualizing the New York Times. There's a distribution at the top. So moving down here is the rank of the word in terms of frequency, and this is their average happiness. So these are common words at the top. War and funeral over here, one and love. These are much rarer words down here, relatively. So the succeeded is down there in pleasure. There's wars and rape are down here. These are less common words in the New York Times corpus. The story here is that, and this is another way to look at it, is that these are deciles being showed, jellyfish plots, is that there's a sort of a scale invariant nature to the emotional spectrum of the English language, which is so this gives us a very funny kind of aspect to this hedonimeter thing that we're creating. So as you move down, so rare words have this uneven distribution with a positive bias. Very common words have that as well. It's roughly true as you keep going down. So that's surprising. I think, well, I didn't ask you what you might think beforehand, but you could imagine, say, that the common words are more positive or something. This could be a very skewed story. Or that as we go to rarer words, valence disappears, but it doesn't seem to be the case. So this emotional spectrum is repeated and, if you like, in a scale invariant way according to frequency of usage. All right, so there's a lot on this slide, but this is distribution that I've just been showing you. One thing we can do is we can, in a way, naturally create or find stop words. We can say, all right, let's go to the most neutral word, and then we'll just move a window out and we'll throw all those words out. So we'll get the and of and so on. But we'll also get rid of some words that have high variance, right? People aren't sure about, some of the swear words will disappear. So as we do that, now we have this tunability to it. We're just going to use these words to evaluate a text. This is actually from Twitter. It's a long time series over many years. And this correlation is trying to show you that as we once we start up to about a width of 1 out to a width of about 5, then these time series all look the same. They all correlate with each other. The average goes up because there's more positive bias in here. But what we can now say is, well, we can tune it, and you can get different words for your appearing for your evaluation. I'm trying to show that with this. This is a crazy plot, but basically the size of each of these words is how much it contributes to the score. So you can see no and love and so on. So as you move away from here, we have more positive, more negative, and as we go up, their frequency is larger, right? So these are very infrequent words. Of course, there are many of them. You can see this kind of, it's like a bad picture of someone's lungs. Over here, there's a denser piece, which is the positivity bias, what we call the positivity bias. So we can open this window up, and if we do that, then you're evaluating with a different set of words, and eventually they disappear. And if you get out to the edge, you see a lot of swearing and negativity and love and ha 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 and those sorts of words over here. So this is like being able to change the contrast of a picture. Let's maybe use that analogy, right? So you have your nice picture, and then you change the color. You can see the boundaries and the borders. It's sharper. You're using less data eventually, so the whole thing will turn into static. But it's a way of getting a clearer, sharper comparison. All right, we know all about Twitter. Twitter, of course, has a lot of quotidian element to it. So this is breakfast, lunch, and dinner being mentioned, which gives us some sense that we could in real time measure how people are doing. This is not good for chicken. This is the usage of the words hungry, starving, food, eat, and chicken, which all follow similar patterns, as I showed you swearing, had a remarkably stable, consistent thing. This is people writing ha-ha. So ha is a funny word. Ha-ha-ha is used a lot on Twitter, expresses something. It gets a little weird when you get out to here, but in terms of frequency distribution, it's pretty good. All right, so maybe this is where I'll get to. So we have this time series now that we've created for Twitter. And of course, demographics are changing. We're not just about Twitter. We want to look at all sorts of data sets. But what you notice when you look across the whole thing is that the spikes in happiness, there's a couple of big pieces here. The spikes in happiness are predictable, right? So it's Christmas and Valentine's Day and so on. People are using, they're just talking about the day. Thanksgiving's a good day. The negative ones are all unexpected. So there's swine flu in here. This is Michael Jackson's death. There's a tsunami here. There's a complicated one is the death of Bin Laden, which is a very emotionally fraught kind of day as well. So endogenous, or sort of exogenous, I should say, exogenous unpredictable shocks are giving rise to these big negativity drops. And there's a strong weekly cycle. And it's Tuesday that's really the drop. All right, lots more detail. You can find all sorts of things. Again, these comparisons of words, right? So this is the royal wedding, very happy. So Osama bin Laden's death is a complicated day. So you see celebrate, you see these positive words, you see less of no, but you see all these negative words. It's a very negative thing happened to a negative character. So yes, we have points on a line, but then we blow them up to this more detailed story. Okay, so what we've got now online, so this is about to come online, is what we call this, well, it's hedonimeter.org. It's not quite open for public, but we're trying to build this thing as something that can go up against the GDP. So this is, of course, just Twitter going in here. There are little popovers that show you these word shifts. Maybe, well, it's almost fully operational. It's getting there. So this has been a big a lot of work. And eventually it's not, of course, going to be Twitter, it's going to be BBC, all sorts of things. All right, so I think that is, I'm going to flip through something. So we looked at all sorts of other stuff. That was sort of the big story. So you can measure whatever you like, right? So happiest cities, so Napa's at the top here. We have other places in California. Saddest ones is Beaumont, Texas, Flint, Michigan. So there's some sort of reasonable things. I'm just showing you some tiny little details. The obesity in tweets, this was my happiness thing. Obesity rate going across here. This is usage of the word McDonald's. This is usage of the word brunch, goes the other way. So that's fun. And if you just then say, all right, well, let's not think about words that we're choosing, let's just find, let's just search through the whole thing. So these are words that anti-correlate with obesity. Brewery, restaurant, bar, so there's definitely an affluence aspect. Hashtag vegan is in here. Ones that correlate with obesity, well, there's eat. McDonald's, wings, hungry, heartburn, and ham. So, I don't know, that's some exploratory stuff that's some good fun. But we have many more demographics, and we can tell a story with that. Last thing I want to say is that we're moving to phrases. And so we have a pretty simplistic way of pulling out phrases. This is not n-grams. What we want is a mixed n-gram story. So we want to eventually have sort of a zip distribution which has words and then bigrams and trigrams and so on. And so this is music lyrics. So if you go through with this method we have, so I know you, you know I, and I know. These kind of things pop out as being salient little molecules in, say, music lyrics. And they're different, depending on the corpus, but that's kind of amusing, this is the whole node business. I think we're good. This is what we're going to. 10 more languages, other input streams, and we're going to get this phrase-based stuff working. So I think I should stop talking. Thank you.
Any questions? Okay, I have a question. So this is more of a textual analysis. There's a
it's a text, yeah. I mean, we're
a lot
digging
of
for words, yeah.
Different physiological analysis. Ross Picard does at the Media Lab.
Yeah.
Is there a way you're thinking of merging them to get a more realistic?
To get physiological stuff as well? I know some people have done that. I mean, that's something maybe we could do. But Schweitz has done some of that, hasn't he, Dirk? You're answering an email. Yeah. But I think they've done that. They've hooked some people up and tried to see how they react to comments in front of them and so on. It's absolutely fair enough. I mean, we have a long way to go in terms of getting this thing connected to. So we're connecting to demographics. So it's one way of getting it calibrated, if you like. But yeah.
Have you also tried to relate it to the work on text analysis and common sense databases like OpenScience, and there's a common sense database to
Okay.
these things?
Yeah. We should. I'd be happy to talk about it.
Okay.
Yeah.